Hi everybody, my name is Marchese and in this presentation I will describe my PhD research on the conversion of industrial CO2 into Fischer-Tropsch compounds. As a matter of fact, there is a correlation between the rise in climate change events with the rise in CO2 emissions toward the environment. Accordingly, different pathways have been proposed to reach carbon neutrality in the upcoming years. However, our society is still reliant on carbon-based materials. For instance, if we look at fossil waxes used in the chemical sector to produce several end products, it is forecasted a rise in their demand. Moreover, they have no commercial alternative to fossil route available at current date. However, as stated by the International Energy Agency, to reach their carbon neutrality, we need to switch from conventional to innovative routes. In my PhD, I tried to solve this problem studying several CCU routes, with a combination of experimental and process modeling activities, capturing carbon material from distributed endpoint sources, using hydrogen, and connecting conventional and innovative technologies to generate Fischer-Tropsch compounds. Firstly, I performed the experimental activities on Fischer-Tropsch catalyst and used experimental data to derive a kinetic model capable of describing the Fischer-Tropsch distribution up to carbon number C8. Then I used the kinetic information to study several process routes with techno-economic considerations. As results, the best option was identified in the capture of CO2 from biogas coupled with high-temperature co-electrolysis to further generate FT waxes. Similarly, I have found that digested gasification to Fischer-Tropsch is the least fluctuating option with respect to the cost of electricity, and that capturing CO2 from the air is beneficial for the environment but has poor economics due to its low technology readiness level. Lastly, using techno-economic results, I identified 73 preferential locations in Europe that cover 8% of the world paraffin demand, with the most profitable location in the north of Germany, having access to low-price electricity thanks to the high wind power availability. However, if we were able to use all the biogas and digestate coming from all biogas plants in Europe, we would cover 80% of the world paraffin demand with a carbon-neutral alternative. A non-field application connected to my research is provided by the European project ICO2Chem, where CO2 capture from biogas is converted into Fischer-Tropsch oils and waxes, and the results are used to validate my models. In conclusion, the routes proposed in this research can be a solution to generate carbon-neutral material, with future outlook that can further validate these processes. Lastly, this research resulted in the publication of several research articles, participation to conferences and workshop, and was defended with honors in July 2021. Thank you.